Hi, I'm Evan Thompson, and I'll be teaching you how to reduce fractions today. So my objective for this lesson is that students will be able to recognize when a fraction can be reduced, and they will be able to reduce any fractions that the teacher gives them. And okay, so I am assuming that my class has already had instruction on equivalent fractions, which is basically an example of this would be changing this 3/4 to 6/8. They're the same value, they've just been shown differently. The 3/4 is fewer slices in the pie, and as you can see, we split up each slice in half. To get 6/8, we basically multiplied the numerator, which is the top number of a fraction, and the denominator, which is the bottom number, by 2. So, in order to get 6/8, we just multiplied the numerator and denominator by 2. And we're going to see today how reducing fractions is very, very similar to doing equivalent fractions. So when you're reducing a fraction, instead of multiplying the denominator and numerator by 2 or by a number, instead of multiplying, you divide, because you're trying to make the fraction smaller. You're trying to figure out what first thing you want to do is figure out the multiple that goes into both the numerator and denominator. This pie that I'm showing you right here is 6/8. Same as this one that we created by making an equivalent fraction up here. So what we did to get from 6/8 to 3/4 is we divided the numerator and denominator by 2. Like I said, it's really the exact same thing as equivalent fractions, it's just backwards. So, I hope you can see this from that far away. I'll write big. So we have 6/8. Can you see that? Yeah, okay, just checking. Okay, so you have 6/8, and then you're trying to get a reduced form. The lowest form you can get. So you look at those two numbers, the 6 and the 8, and you think, what number can I divide? What number fits into both of those numbers evenly? So you think, well, I know 3 goes into 6, but does 3 go into 8? Nope. Keep thinking. 2 goes into 6. Does 2 go into 8? Yes, it does. All right, so you just divide by 2 on both the top and bottom. So then you just go across. 6 divided by 2 is 3, and 8 divided by 2 is 4. So there you go, you get 3/4 with it, which is shown right there in this pie. Basically what we did there, like with our equivalent fractions, I'm going to keep referring back to those equivalent fractions because they're very, very similar. With these equivalent fractions, what we did was we split the slices. But with reducing fractions, we're joining slices together. As you can see, just like with the equivalent fractions, the same amount is colored in. See? Same exact amount is colored in. The value does not change. These fractions, even though 3 is smaller than 6 and 4 is smaller than 8, that doesn't mean that there's less pie. You get 3 slices out of 4 slices of the same size pie. This one you would get 6 slices out of 8 slices in a pie. So, yeah, all right, we're going to do another example. let me move my stuff around. Okay. Hope you can see that okay, yes. Alright, so you see this pie? There are 9 slices in this pie. There are 3 slices colored in. So 3 out of the 9 slices are colored in. Alright, now what do we have to do? We have to reduce this fraction. So we look at those 2 numbers and you think about what number goes into both of those numbers evenly. 3 goes into 3. Does 3 go into 9? Yes, it does. Alright, so we would divide by 3 and divide by 3 on the bottom too. Wherever, if you divide on top, you have to divide on bottom. You have to divide by the same number on both the top and the bottom. You can't leave one of them lonely. They have to have a buddy. And 3, they both want to be buddies with 3. So you gotta be fair. So, alright, so you divide 3 by 3, and that is 1. And then 9 divided by 3 is 3. So we get 1/3, 1 over 3. And as you can see, this pie has 3 slices total, but only one of the slices is colored in. By dividing, basically what we did was we joined each 3 slices together. So like these 3 got put together, these 3 got put together, and these 3 got put together. Alright, now like I said, you want to keep in mind that just because the numbers get smaller doesn't mean that the value of the fraction changes. Just like with the equivalent fractions we learned about. Even though the numbers are getting bigger, that doesn't mean that the value changes. It doesn't mean that it becomes a bigger fraction. Okay, so yeah, I mean I could show you some examples of problems you would do for the class. Oops, gotta erase. Okay, so some examples are like this top one. You see half the circle is colored in. Same with this one. And basically what you would have to tell me is what would you divide by if you started out with 3/6. Start out with 3/6 and you would have to find what number goes into both of those numbers. And then you would have to divide and write the numbers that you get from dividing. So in this case, you would divide 3/6 by 3 on top and bottom. So you would put it in these boxes. Remember, you have to do it on top and bottom. They need a buddy. So divide by 3 on top and bottom. 3 divided by 3 is 1. 6 divided by 3 is 2. So we get 1 over 2. There's 2 slices total. Alright, so I'm running out of time, but I really hope this helped you, and I hope this was sufficient. Alright, and yeah, thank you so much for watching. Bye.